Good morning, my lovely kiddos and my future mathematicians. Today we are going to be going over day 1 of our study guide. Remember that our test is this upcoming Thursday and Friday, May 13th and 14th. Today we're going to go over 4 problems. For our study guide, we're going to go over 4 problems today, a couple more tomorrow, a couple more Wednesday to get ready for our test on Thursday, Friday. Okay, so this first problem, we start off with a right triangle, which is awesome because chapter 9 has been all about right triangles. We have the side lengths of 10, 20, and x. And we want to solve for x here. All right, if we remember back to last Thursday, 9.6b, then we can remember that if we have 2 side lengths, if we already know 2 side lengths, which we do, we know the 10 and the 20, and we want to know that third missing side, we could use the Pythagorean theorem. Now remember that our Pythagorean theorem is a squared plus b squared is equal to c squared. Where a squared and b squared, those are our legs. Okay, so remember our legs are the 2 sides that touch this 90-degree angle. So our 2 legs are 10 and x. It does not matter which one goes in for A and which one goes in for B, as long as they're both legs. And then our c squared here is our hypotenuse, or our longest side. The side opposite of our 90-degree angle, or this 20 here. All right, so I'm going to plug in 10 for A, so 10 squared plus x squared, our other leg, is equal to our hypotenuse of 20 squared. 10 times 10, or 10 squared, is 100. X times x, or x squared, is still x squared because we don't know what x squared is. And 20 times 20, or 20 squared, gives us 400 here. 100, to get x squared by itself, we have to go ahead and do the opposite operation to that 100, which would be to subtract that positive 100 once from each side of the equal sign. Positive 100 minus 100, those are going to cancel because they add to 0, leaving us with just that x squared. 400 minus 100 gives us 300. And that tells us what x squared is, but I want to know what x is. So to get rid of this squared, we are going to have to use the square root once on each side of the equal sign. The square root and the square, those are going to cancel out, leaving us with just that x. And since this problem did not ask us for a simplified version of our radical here, it did not want us to do a factor tree. So I am totally fine if we just plug this into our calculators and we get 17.320. Remember, I want 3 numbers after the decimal place here. All right, number 2, we have another right triangle, which is good because we've been learning a lot about right triangles in chapter 9. We have the side lengths of 5, 13, and y. Again, plugging in our legs for x or a and b, and then our hypotenuse for c. We're going to use the Pythagorean theorem because we know 2 sides and we want to find that third missing side. So I'm going to plug in 5 in place of a, 13 in place of b because those are our 2 legs. They are touching the 90-degree angle. And then y for our hypotenuse. 5 times 5, or 5 squared, gives us 25. 13 squared, or 13 times 13, gives us 169. And y times y, or y squared, gives us just y squared because we don't know what y is. 25 plus 169 gives us 194 is equal to y squared. But again, I don't want to know what y squared is equal to. I want to know what y is equal to. So we are going to go ahead and square root once on each side of the equal sign. The square root and the square are going to cancel, leaving us with just that y. And then 194, the square root of 194, we're going to get a decimal approximation for, and it gives us 13.928. All right, number 3. Another right triangle with the side lengths of 19, 17, and z. All right, so again, we're going to plug into the Pythagorean theorem because we know 2 of the side lengths and we want to find that third. Okay, so we want to plug in our 2 legs, the 2 sides touching this 90-degree angle in for A and B. So I'm going to put z in place of A, so z squared plus 17 in place of B is equal to our hypotenuse 19 in place of C. All right, so z times z, or z squared, is just going to give us z squared because we don't know what z is. 17 times 17, or 17 squared, gives us 289. And then 19 times 19, or 19 squared, gives us 361. In order to get z squared by itself, we're going to have to subtract 289 once on each side of the equal sign. Positive 289 minus 289, those are going to cancel because they go to 0, leaving us with just that z squared. And 361 minus 289 is going to give us 72. Again, we don't want z squared, we just want z, so we're going to have to square root both sides. Square root and square, those are going to go ahead and cancel, leaving us with just that z. And the square root of 72 gives us 8.485. All right, the fourth and final problem here today is a little bit different than the other ones. This is a word problem. Okay, so I'm going to draw a picture and read us the word problem as we go along. Okay, so first sentence says there is a pond. So I'm going to draw a pond here, and just so we know it's a pond, I'm going to draw a cute little fish here. Beautiful little fish here. Okay, and we want to go from point A, which is at our campsite, to point B, which is the dining hall. Okay, we want to go from A to B. So this word problem says that to get from point A to point B, and we have to avoid walking through the pond at any point. And so to avoid walking through the pond, from point A, we walk 34 meters south. So 34 meters south. Okay, and then from that point, I'm going to call that point C, we are going to walk 41 meters west. Okay, since we went from south to west, we know that this angle C is a 90-degree angle. Okay, this problem is asking us to find the shorter distance here between just going through the pond, either swimming or riding on that huge fish's back at any point, to see how long our hypotenuse is, how much time would we have saved. So again, we can see that this is another Pythagorean theorem question. We have our 2 legs. We want to find our hypotenuse. So I'm going to go ahead and plug in 34 in place of A, 41 in place of B, and just C in place of C. So 34 squared gives us 1,156. 41 squared gives us 1681, and that is still equal to C squared. All right. Then when we add these together, we get 2,837 is equal to C squared, and we run into the same problem. We want to know what C is equal to, not C squared. So the square root and the square, those are going to cancel, leaving us with just that C. And then the square root of 2,837 is going to give us the decimal approximation of 53.263 meters. Okay, I use meters because that is what they gave us here.